But did you guys hear the big news this week? They're making a new Matrix movie. Is everybody psyched? I don't know what the story is going to be. I'm just really hoping that the title is Matrix 4, Gradle Sync Failed. So I'm here to talk to you today about adding Flutter to your Android app. For those of you that don't know who I am, my name's Matt Carroll. I'm a developer on the Flutter framework team at Google. Now, how many of you are generally familiar with what Flutter is, like why it exists? Okay, most of the audience. How many of you have written at least some lines of Flutter code? Still most of the audience. Now here's the hard one. How many of you have shipped lines of Flutter code to your customers? Only a couple. Okay, we got to do better with that production launch scheduling. Before the uninitiated, let's start with a brief discussion about what Flutter is. So Flutter is a UI toolkit. You might be wondering, okay, well, what isn't a UI toolkit? The important thing there is that it's not an application framework. It's not meant to tell you where all the things in your application live and how they operate. It's a tool specially designed to help you build beautiful user experiences. Now, Flutter is based on 4 pillars. These are kind of the 4 principles behind Flutter. Flutter should help you build beautiful user experiences. You should be productive when doing it. It should execute fast or quickly at runtime, and it should remain an open ecosystem. So these are the things that guide us on a daily basis as we decide what to build and how to build it. So let's start just looking at some what I would consider beautiful UIs and what we mean by that. So there are hundreds of examples of Flutter user interfaces, and what stands out to you maybe isn't what stands out to me, so you can go browse through the options if you want to see more. But what you see behind me are some experiences that I would say show a future trend in mobile app development. Historically, we've operated screen by screen with these discrete user experiences. But over time, our users have come to expect more of a continuous user experience, a UI that transforms and adapts, where it's not clear where one screen ends and another screen begins. Flutter does a good job of making this possible, whether it's Flutter's declarative UI or the specific APIs that Flutter offers you. It's much easier than traditional methods to create these kinds of user interfaces, and this seems to be where the UI and UX trends are going. But not only can you take your existing UI to the next level, but you can also begin to explore some future-looking ideas. You can try to innovate UI concepts. And just to explain what you're seeing here on the left, for example, is a vector animation. It's not video. It's animated live with Flutter. It includes bones and mesh deformations, and it's running at 60 frames per second. So there's a lot of interesting things you can do by integrating with those capabilities. And over on the right, you see something that's, you could imagine something like that at a science center. It's a highly engaging, almost game-like experience, but it's still an application. Now, if I told you that, okay, you can build these cool user interfaces, but it's going to take you twice as long, you'd say, no thanks, I'm already short on time. Fortunately, Flutter actually makes you faster when creating these user interfaces, and I would suggest it also is pretty fun at the same time. Now, there are 2 major ways that Flutter does this, at least in my opinion. One way is by offering a declarative syntax for user interfaces. So one, this allows you to write a small fraction of the volume of code that you were writing before, but I think equally importantly, it actually allows you to structure your code the way you think about the user interface in your mind. You're not artificially putting things together or taking them apart for, let's say, performance reasons. You're not worried about being more than 3 levels deep in your view hierarchy. The way you think about the UI is the way you structure it declaratively with widgets. But in addition to that, as you make changes to that declarative UI, you make changes in your code, you press save, within about 200 milliseconds, you can see those changes live on your emulator, simulator, or physical device. So you're in this 200 millisecond feedback loop. You can put a designer right next to you. You can put a customer right next to you, and you can iterate on ideas. But additionally, for those of you who are just now getting started with Flutter, you can also learn the API by coding and pressing save. You don't need to spend all day in manuals. You can actually just poke at it until you develop a mental model for how Flutter works. All right? That then leads to the question, how do you use Flutter? How do you get started? The easiest way is to simply create a new project. So when you create a new Flutter project, you get an Android app and an iOS app within the project for free. So you can start writing Flutter code and you're off to the races. But my guess is all of you are here because you have an existing Android app. So what do? It's really easy. You just get a clicker that works, throw your app away and start over, right? Start over in Flutter. And I can see that some of you are looking at me like this. Obviously, I'm joking. Well, I'm half joking. We've actually been surprised at the number of teams, including some very large ones, that decided to get rid of all of their existing Android code and start over with Flutter because their velocity was so much higher. But I don't expect all of you to do that. We know it can't be a requirement. So we're putting a priority effort into helping you integrate Flutter with your existing app, which is really what we're here to talk about today. I do want to give you a warning, though, before we go any further. Everything you're about to see is technically unstable at this moment in time. It's available on the master branch. You can use it, but our recommendation officially is that you wait until it becomes stable to ship it to customers. All right, so if it breaks at this point, it's my fault, but it's not my fault. I warned you. So the first thing for us to figure out is how to take your Android project, this Gradle project that you have, and somehow bring Flutter into it. How do we do that? What does that mean? Well, there are two steps we're going to take. First, we're going to create a Flutter module project, and then we're going to link that existing Android app that you already have to the Flutter module project. So it's two steps. Create the Flutter module project, and then link them. So first, we'll create the Flutter module project, and if you have the Flutter plugin installed for Android Studio or IntelliJ, you have a normal new project wizard, and all you have to do is select the option there on the right instead of the option on the left. That's all it takes. You go through the next step, you tell it where you want your directory set up, what you want the name to be. You can do this at the command line. I just didn't want to bother you with that at this stage. So you go through the wizard, and you'll end up with a structure, a project structure, something like this. Most of what's here you don't have to care about. I just want to draw your attention to two things. Up there at the top is a .android directory, and if you look at some of the files in there, you'll notice it's a Gradle project. So your Flutter module project contains within it an Android-based Gradle project. And then if you're curious where your Flutter code lives, it's under that lib folder. I know that we as Android developers are used to lib, meaning libraries or dependencies. In Dart, lib is where your source code goes. So I just wanted to make sure everyone's clear on that. So this should now give you the notion that we have an existing Gradle-based project with our Android app, and we have a Flutter module project that also has a Gradle project, so surely there's some way to connect these things. And there's actually two different ways that we offer to connect them. The first is that you can build an Android archive from your Flutter module and consume it in your Android app like any other Android archive. The second option is to actually link project to project, and we'll go through both of those options. So let's say you want to consume an Android archive. You'll go into your Flutter module project, open a terminal, and you'll run flutter build AAR. Now this will soon be available in the IDE. We'll have a pretty little button that you can press and it will build that AAR. But for now you'll have to run this from the command line, and this will output an Android archive within your build directory in your Flutter module project. So now we've packaged up the Flutter stuff. Now we need to consume it in your existing Android app. So for that, we go to your existing Android app, open up your build.gradle file for your app module, and define a local Maven repository. You may already have some repositories defined in there, maybe not. You'll add a repository section if you don't already have one, and then you create a Maven specification that actually points to your Flutter module in the build directory. So some of you may have set up local Maven repos before. There's nothing Flutter specific here. This is just Maven Gradle interaction. So we point your app to that repo, and that links it. That lets your app project know about the Flutter module repo, but now you have to tell your app, we actually want to consume the Android archive. We want to compile it into our Android app. And that's what the release implementation target is there at the bottom. So for the most part, you can copy and paste this, with the exception that you need to adjust your local path for your Flutter project, your Flutter module, and whatever package name you use in your Flutter module, you need to replicate that under release implementation. But at this point, when you build your existing Android app, you will now have your Flutter experience compiled into it. You're good to go. You might be wondering, why do we have these two different options? Why Android Archive and project linking? Well, if you consume an Android Archive, anyone who works on your project can work on it even without having Flutter set up, because it's an Android Archive like any other Android Archive. What you're about to see is a project-to-project link, which actually requires that Flutter is set up. So then you might say, well, why would anyone want to do that? Well, the downside to consuming the Android Archive is that every time you change your Flutter code, if you want to see it in your Android app, you need to run Flutter build AAR again to build another archive. And that can be a bit of a pain. So the alternative to that is actually linking the projects. So if you wipe away everything we just said about building an AAR, if you open up the settings.gradle for your existing Android project and essentially copy and paste this code in there, and you change the path to your Flutter module, this will now tell your Android project that there is a Gradle module called Flutter and link it to your Android project. So that now all you have to do is go into build.gradle and add an implementation dependency on that module. And this will probably look very familiar to you, because if you've ever had another module in your project, this is how you depend on it. So the upside here is every time you build your Android app, you will rebuild your Flutter app and everything will be up to date. The downside is that everyone on your team will need to have Flutter set up. Okay? So now we've linked the two projects. You're compiling Flutter into your existing app, but I haven't told you anything about how to actually display Flutter. So let's talk about using Flutter with Android. We're jumping through a number of topics here in this presentation. So I'm going to tell you what you're about to see, and then we'll see it, and then I'll tell you what you saw. Okay? So we're going to look at launching Flutter as a full screen experience. We're going to look at displaying Flutter as a fragment. We're going to touch very briefly on displaying Flutter as a view. And then we're going to talk about the very important topic of initializing Flutter before you need it. So let's start with Flutter as a full screen experience. We're Android developers, and we know a full screen experience means an activity, right? And how do we usually launch an activity? Maybe we've got an on-click handler in one activity, and then within that we say start activity, and we create an intent, and then that launches the next activity. So wouldn't it be nice if there was some kind of Flutter activity where you could launch it the way you'd launch any other activity? And it would be unfortunate if I didn't have that to give you on the next slide. So here it is. Here's Flutter activity. So let's say you want to launch a full screen Flutter experience. All it takes is calling Flutter activity.create default intent, and now you have a launchable intent that will show a Flutter experience. If you haven't made any significant changes to the Flutter module, the create default intent is really all you need. So for most of you, this will get you started right here. But there are some things you can configure in that Flutter experience. So for example, Flutter includes the concept of navigation. You don't have to use it, but if you choose to, then you might want your Flutter screen to begin at a particular route, let's say. So to accomplish that, we can use a slightly different intent builder. And for now, I'll say ignore the with new engine part, but that gives us an intent builder. And then we can customize the initial route. So a user profile route, for example. And here again, that's all you need. Launch the intent, and you're good to go. So that's actually all there is to a full screen Flutter experience. But as we know, full screen is not always what you want. Maybe you have a single activity app. Maybe you have some tabs in that app, and you have some Android content, but then you go to tab 2, and now you've got Flutter content. How do you accomplish that? Well, in most cases, you do that with a fragment. So let's talk about how you launch a fragment. This will look very familiar to all Android developers. We get the support fragment manager, we begin a transaction, we add a fragment to it, and then we commit the transaction. And adding the fragment is as simple as calling flutter fragment.createDefault. Now this isn't giving you back an intent because that's not what we want here. It's giving you back an actual Flutter fragment. But here again, the defaults will work most cases, but if you want to customize it, you can do that as well in virtually the same way that you did for Flutter activity. So now you can set the initial route. So now you're saying, okay, but our company doesn't use fragments, we don't like fragments. I hear you. The only option left for you is Flutter as a view. And frankly, the only thing I'm here to tell you about that today is to warn you that you probably don't want to do that. So there is a Flutter view, and you can use it. In fact, in Flutter activity and Flutter fragment, both of those use Flutter view. The thing is, Flutter view requires a lot of calls forwarded to it. Lifecycle callbacks, permission requests, low memory callbacks. And so you take on the responsibility of forwarding those if you choose to drop down to this level. It's also the case that of all the APIs we're talking about, Flutter view is probably the most unstable. We feel pretty good about it, but there will be some changes in the coming months, okay? So you can use it, but all I'm going to give you today is a warning. Now, the last thing in this section I want to talk about is Flutter initialization. So if you follow the steps exactly as I've told you today, you have your existing Android experience. You call start activity for a Flutter experience. And for a moment, you see this. You see a blank screen, black or white, and then your Flutter experience appears. And you're like, what's going on here? Why is this blank screen showing up? What you have to understand is that behind every Flutter experience is something called a Flutter engine. And when Flutter engine is starting fresh, it's responsible for setting up a number of dedicated threads, it's responsible for bootstrapping Dart execution, and it's responsible for pumping and rendering the first frame of your Flutter UI. These are non-trivial operations. It takes some amount of time. But what you can do is pre-warm a Flutter engine so that it's ready to go when you are, and you can cut that time way down. And I'll give you some numbers. So we tested this on a Nexus 5X. I think that device came out in 2015 or thereabout, so it's by no means a new device, but it's also not an antique. Without doing any pre-warming, we saw about 1,500 milliseconds from the moment start activity is called to the first frame of Flutter being rendered. Doing what I'm about to show you, that number drops down to about 300 milliseconds. So we strongly encourage you to pre-warm a Flutter engine whenever you can. So let's take a look at how to do that. Somewhere in your code, and this could be in your application class, it could be in your own, maybe a static method somewhere, or your own DI system, whatever makes sense for your app, start by instantiating a new Flutter engine instance. All it needs is a context. Now this just gives you a Java object, nothing important has happened yet. To do the work, to really pre-warm it, we need to start executing Dart code. To do that, we take that Flutter engine, we get the Dart executor from it, and then we tell it to execute a Dart entry point. And again, for any typical use case, the code behind me is exactly what you need. You don't have to worry about changing the entry point. But this starts the Dart execution process moving. It happens asynchronously, so this won't block whatever thread you're on. But now you have a pre-warmed engine that will drop that time way down. The last thing you need to do is make your pre-warmed Flutter engine available to your Flutter activity or Flutter fragment. So how do you do that? We provide a Flutter engine cache. It's available as a static singleton, so you get the instance, and then you put your pre-warmed engine in that cache. And you might be wondering where this ID comes from that you see here. It's any string that you want. This is your cache. Put however many engines you excuse me, however many engines you want in there, give them whatever IDs you want, it's up to you. You just need to remember what that ID is. Because when you want to use that Flutter engine in Flutter activity, you're going to call a slightly different method on Flutter activity, this time with cached engine, and you're going to pass that ID in. Then when your Flutter activity launches, instead of creating a new engine, remember that method with new engine, instead of creating a new engine, it uses your cached engine because it knows how to look it up in that Flutter engine cache. So now again, we've gone from 1500 milliseconds down to 300 milliseconds on that Nexus 5X. Same exact thing for Flutter fragment. Flutter fragment.with cached engine pass in the ID. All right. Now, a real quick note for those of you getting super excited and you want to go try this right now, just be careful with your class paths. We've had some duplicated class names over the evolution of this code. What you're looking for is what's in io.flutter.embedding. If you use what's under facade, you will be very disappointed and you will have memory leaks and it'll be a disaster. So don't do that. Use the class path there at the top, okay? So here's what you've just seen, in case you've already forgotten. We launched Flutter as a full screen experience. We displayed Flutter as a fragment. I warned you about using Flutter at the view level. And then we looked at initializing or pre-warming a Flutter engine and using that in your Flutter activity and Flutter fragment. Now, I've talked a lot about how to use Flutter with Android. But when I first started using Flutter, I had a lot of fun with it. It was a lot of fun jumping in and playing with widgets. But eventually I realized I had no idea how Flutter actually works on Android. And that kind of scared me. It's fun for prototypes, but shipping something to customers that you don't understand is kind of a big risk. So with the remainder of the talk today, I want to kind of pull back the curtain on how Flutter actually integrates with Android. Let's start at a high level and talk about rendering pixels. I'm going to speak kind of broadly about how rendering pixels works in a couple different cases to draw an analogy to Flutter. So let's imagine that you are rendering video to the screen of your device. How does that typically work? Well, whether you have a file locally with encoded video data or you have a server that streams encoded video data, eventually it gets to your device and then it goes into some kind of video decoder, which takes the decoded data and paints a texture in the GPU. And then that texture that's painted in the GPU is copied to the screen of your device. And that's how you actually see a frame of video. Similar, let's look at video games. So you have some kind of scene graph in your game engine. And that eventually is reduced to primitive data structures, which are sent to OpenGL or Vulkan or Metal or one of those systems, which paints a texture in the GPU and then copies that texture to the screen of your device. This is how you see the video games that you play. So now let's talk about Flutter. Flutter has a framework side, which is where all the Dart code lives. That's where you're setting up your widget trees and writing all your application UI behavior. But eventually at runtime, that information boils down to primitive data structures, which are sent to the Flutter engine, and the Flutter engine then paints a texture, and that texture is copied to the screen of your device. And this is how you see Flutter pixels on your screen. All right? But Flutter isn't just pixels. It's not just a fancy painting or fancy animations. It's an interactive experience with touch input and keyboard input and accessibility interaction. So how does that work? How does Flutter integrate with the Android framework itself? Well, let's start here with this hypothetical Flutter experience on a device. Let's get rid of the system Chrome and the device, and we're left with the Flutter activity, which you've already seen how to launch. You're familiar with that. Well, like any other activity, there's a view hierarchy in there. There are specifically two things in a Flutter activity. At the top level, there's a Flutter view. Flutter view does not render any pixels. What Flutter view does handle is all the user interaction, the touch input, the mouse input, the keyboard input, the accessibility interaction. All of that is implemented in Flutter view. And then within it, or kind of visually beneath it, you either have a Flutter surface view or a Flutter texture view. Which one you have depends on some details about whether you're rendering with transparency and things like that. But you have one or the other. And that's where your texture gets displayed. That texture that gets copied to your device screen, that's where it gets painted right there in one of those two views. And those two things combined is the actual implementation of Flutter activity and Flutter fragment. But let me get specific here. Let's talk about touch input. If you jump into Flutter view, you will actually see overridden methods for onTouch event and onGeneric motion event. Now, out of curiosity, how many of you have ever overridden these methods in your own career? 1, 2, 3, a few of you. So I almost don't want to know why you're overriding those, because you probably had to do a whole bunch of work. But most of you are probably used to adding on-click listeners and long press listeners and gesture responders, things like that. Those are all at a much higher level. Eventually, they boil down to these methods here. These are raw input events. So what we do with Flutter View is we take those raw input events and we forward them to the Flutter framework. So those actually get sent over into Dart code. And it's Dart code that recognizes gestures, taps, long presses, drags, all of that is recognized in Dart. And one of the reasons for doing that is that we can take the same gesture recognition logic and we can use it on multiple platforms, like iOS. But these are standard Android methods, and that's the most important point. Android was made to send you this information, and you can handle it however you want. We've chosen to handle it by sending it over to Flutter. So we're not circumventing Android, we're not suppressing it, it's not a hack, it's just normal Android View implementation. Here's an example of some keyboard input. So we've overridden these methods in Flutter View. So when onCreateInput connection is called, we return a Flutter implementation of an input connection. When we get onKeyUp, onKeyDown, again, we forward those over to the Flutter framework. Mouse interaction, we forward hover events. Accessibility interaction. The implementation here is a little more complicated, but again, from a Flutter View perspective, what it comes down to is that the framework says, would you like to provide a custom accessibility node provider? We say, yes, we would, and we give back one that knows how to talk to Flutter. And so to be clear, Flutter fully supports accessibility. So when there were some talks yesterday about accessibility. Some of you may have heard about TalkBack, for example. Flutter fully supports TalkBack. You get the green outline anywhere in the Flutter UI, and it announces to you the widget that's in your Flutter UI. And this is fundamentally how we implement that at the Android level. How about Flutter Surface View? At the beginning, it just extends Surface View. How many of you have ever extended Surface View? How many of you have extended Texture View? Less on the texture. I'm actually surprised. Surface View is older, but there's fewer of you that have extended Surface View or Texture View. Okay, so Flutter Surface View, you never would have guessed by the name, but it extends Surface View. And anytime you do that, most of what you need to do is to respond to a few callbacks. So the framework notifies us as a Surface View, hey, your surface is now available. It's been created. So what do we do here with Flutter Surface View? We take that surface, which references a texture, and we tell Flutter, you now have a texture to render to. Remember, because Flutter paints textures. So we send that over to Flutter. We say, here's your texture. Do whatever you want. Eventually, the framework says, hey, you've changed sizes. So we say, Flutter, you've now changed sizes to this width, this height. Update yourself accordingly. And then eventually the framework says you no longer have a texture or a surface, so clean yourself up. We send that message to Flutter, take care of cleaning up that texture. It's almost the same exact thing with Texture View. The only difference here is there's one additional callback. So once again, you have a texture available, start rendering. Your texture has changed sizes, update yourself. A new frame has been rendered to the texture, do whatever you want. And then eventually, your texture's gone, make sure you've cleaned up all your references. So those are the two different ways that we get those painted Flutter pixels onto the screen. And this is how, technically, Flutter integrates with Android. Now, I know the Dart side is much more complicated, lots of stuff going on there, but again, this shows you where the boundary is. So when you start using Flutter, it's not just one big magical black box. You now know where Android ends and Flutter begins. Let's do a very rapid recap of everything you've heard so far. So Flutter needs to render pixels. It needs to get those pixels onto the screen. It does that by painting a texture and then copying that texture to a Flutter Surface View or a Flutter Texture View. But that's just painted pixels. We also need interaction. So we wrap that Flutter Surface View or Flutter Texture View with a transparent Flutter view. That gives us touch support, keyboard support, mouse support, accessibility support. At this point, you have a fully interactive Flutter experience. But for you as developers who want to use this, we make it available to you either as a Flutter activity or a Flutter fragment. Now, Flutter activity and Flutter fragment, along with Flutter View and Flutter Engine and all these other classes, are available in what is called Flutter's Android embedding. If you look around the repo, you look at our docs, you'll see that name repeated, Flutter's Android embedding. And Flutter's Android embedding is available in every Flutter module project, which I showed you earlier how to create. If you then take that Flutter module project and you link it to your existing Android app, your existing Android app now has access to Flutter Activity and Flutter Fragment. So this is how Flutter actually integrates with Android, and this is how you add Flutter to your existing Android app. And with that, I'd be happy to take some questions. Thank you.